So today we're going to talk about how to solve equations with variables on both sides, okay? So let me give you a first equation, and it's not that different than what we had last time. So first example, it says 20 plus 7x equals to 9x. Okay, only thing that's different is, anybody see the difference between what we had last time and today? Yeah. The variables on the both sides, whereas last time you just had, you had variables on only one side. But is this sort of easy to solve anyway? Yeah. What do we do? Yes, sir. One person knows. Okay, a lot more of you. Okay, Tajwar, what do you think, sir?
You just subtract the variable from the...
Yeah, you could subtract one of the variable from both sides to get rid of it, or add, or something like that. Okay, so which one should we get rid of, 7x or 9x? What's a good? So you have a choice. You could actually either get rid of 7x or 9x. Which one's better, you think? How about Samara? 7x. Why do you say 7x, Samara? You're right. Yeah, it's smaller. Well, so whatever the, if you look at the coefficient of these variables, this has 7, right? The other is 9. Whichever has smaller coefficient, that's the one that you normally want to get rid of because you don't get negative numbers. You see, very good. So I don't like subtracting. So I like. Can I add both sides by what here? Yes, sir. Negative 7x is correct. Claire, can you tell me what to write now? Yeah, put the book away in your backpack, please. Okay, what do I write now? Here. No? No, we're adding both sides by negative 7x. So what do I write next?
20 equals 2x.
That's right. Okay. So Claire, you gotta get ready one more. Okay, so then this is what we get. 20x equals to, actually I even wrote this using the distributive property backwards. You see, 9x plus negative 7x is 2x because it's really 9 plus negative 7, right? Times x, yeah? No, you don't have to. I'm just showing it to you. Yeah, you could just put it as 2x, but I'm just showing you how I got that. Okay. All right. Then Bella, what do I do next? Yeah, you divide each side by 2 because you have 2x there. Of course, the answer is, class? 10. Okay. Oops, let me move that up a little bit. Any question? Is that easy?
Yes.
Okay, you don't have to write this down, but let me ask you, what if I were to get rid of 9x on the right side? So can I subtract both sides by 9x?
No.
Okay, tell me what I get next. This is where people make silly mistakes. Okay, what do I get? Because I just wanted to show it to you. Camilla, what do you think? 20 minus 2x equals 2? Yes, what do you think? Right. So what do you get after you do that? On the left side. So here, what's my next step here, Aaron? That's what I'm asking. Yeah, so same thing, right? Equals to what? 0. Very good. And many times people forget to write that 0. Guess what people do? Anybody? Yeah. Yeah, they don't put 0 or anything. They just write it this way. 20 plus negative 2x. Is that okay? It's 0, so it's okay to not write anything, right? That'd be wrong. How come we have to have the 0 there? Yes, Michael?
Because the x has to be on one side and the number is to the
Right. In other words, if I were to not put, because some people think that, oh, 0 is nothing, so let me just put nothing, right? That'd be wrong, because if you just do it wrote it this way, do you have an equation? No, what do you have now? An expression. Okay, you lost the right side of the equation. Okay, so just because it becomes 0, you know, doesn't mean you don't write anything. Okay, it's a number, right? It's 0. It's not 10 or 5. It's 0. So you have to write it. Okay. Then of course you could, subtract 20 from both sides, right? And then you get the same answer. Does that make sense? So as long as you do it correctly, what I'm trying to say is you get the same answer. But if you get 0, don't just leave it as blank. You know what I mean? Then you don't have an equation anymore. You see what I'm trying to say? You're losing one of the side of the equation. Okay, let's look at example 2 then. Example 2 has, look at example 2. It says 3 over 5x equals to 4 minus 8 over 5x. Look at the coefficient. The coefficient of these terms, the one with the variable, are fractions. Okay, so that's fine. So what do you think we should do first? By the way, which one of these terms should we get rid of? 3 over 5x or negative 8 over 5x? How about Chuck?
Negative 8 over 5x.
Yeah, why? Because?
Because it has 4 on the side. So I mean, yeah, because you don't want 0 on the other side.
Well, yeah, you could actually get rid of 3 over 5x. That's fine. You're right. And then you get 0. It's fine. But reason why we want to get rid of negative 8 over 5 is we want to keep everything positive, right? Which one is the smaller coefficient? 3/5 or negative 8 over 5? Negative 8 over 5, right? No, 3/5 is...
Oh, yeah.
Negative is smaller than positive, right? Look at the coefficient by itself. So that's why we want to add both sides by class what?
Plus 8 over 5.
Exactly. Plus 8 over 5x. All right, and if we do this, okay, Royce, tell me what to write.
Oh, 11 over 5x equals 4.
Exactly. Now, before I wrote that, I actually wrote this out. Do you see why I did that? Because I got some fractions. And I like these fractions because they both have common denominator. You don't have to make them, having common denominator and so forth. But I'm actually going to write this step out because using distributive property backwards, isn't this what we're doing? 3/5 plus 8 over 5 times x, and what we have. And if they didn't have a common denominator, this is where you could actually make them into common denominator by multiplying top and bottom by the same number and so forth. But here, I like these fractions because they happens to have common denominator. Sammy, what do I get here when I have 3/5 plus 8 over 5?
11 over 5.
X, exactly, equals to 4. Now, Paige, how do I get x by itself then in this case? Yeah, you multiply both sides by 5 over 11, which is the reciprocal of that coefficient, right? How do you get rid of 11 over 5 times x, right? So you then multiply both sides by the reciprocal. And when you do this, what do we get here? How about Dana? On the left side, it becomes simply x. And on the right side, it becomes 20 over 11. Any question? And so you could either write x equals to 20 over 11 this way, leave it that way, or you could write it as a set, right? Using the brace, 20 over 11. Okay. Does this make sense?
Yes.
Any question? Easy?
Yes.
All right. May I move on to the next example then? By the way, could you check these whenever you have time? Yeah, always. Whenever you're solving, you can always check. Because all you have to do is go back to your original equation and what? Plug in dx. Even though in this case, sort of fraction. But you can still do it. It's not bad. Okay. All right, let's look at example 3. Okay, let's take a look at example 3. I have 4 times r minus 9 in parentheses plus 2 equals to 12r plus 14. Okay. This time, it's a little bit different than the ones that we had because, well, we have numbers on both sides. But look at the variable, the term with variable. Can I get rid of this r right now as it is? Because this one has smaller coefficient, right? That's just r. Can I get rid of that right now? No. What do I have to do first? Because it's inside the parentheses. How do you get rid of the parentheses? All right. How about Christina? You distribute 4, right? So before I do this, though, I'm going to write it as an addition. Is that okay? Because I like addition. But you could just do that one step if you like. But it's sort of a nice. Angel, can you tell me what to write when I distribute 4? You're right. Like I said, I changed it to addition and I distributed it because I don't want to make silly mistake, right? For getting negatives and things like that. Okay. So, hold on. All right. So then we get this. Now, before I move on, take a look at the left side of this equation. Do you think I should get rid of one of the r, or do you think I should do something before I get rid of one of the r? Look at what's on my board. Okay, Jason. Yeah, I should add negative 36 and 2 together, right, Chris? Okay, what do I get when I do that? Negative 34, right? You should always, what class? Always simplify. Of course, when you're solving equation, you're solving, but before you get to next step, if you could simplify something, it just makes it easier, doesn't it? So you should write this as 4r plus negative 34 equals 2. 12r plus 14. Now, of course, Carla, what do I do here? Carly, I mean. Subtract. Oh, let's gather the ones the variables first. Which one should we get rid of? 4r or 12r? Which one has smaller coefficient? Yeah, 4r. So how do I do that?
Just add negative 4r.
Very good. You add negative 4r to
Oh, to 12.
both sides. Both sides.
yeah,
Right. Okay. So when I do that, somebody tell me what I get here. Song, what do I get?
-34.
Oh, over here. I think that's Song. Okay. Huh?
-34 equals 8r plus 14.
That's correct. Right. Then it seems like did you have a question, Carolyn?
Yeah.
Yeah.
Whenever you're supposed to get rid of the 14, don't you subtract it and then you add the 6?
You could get rid of the 14 first, but I want to gather the variables first, then get the numbers. Is that okay? So actually, you could gather the numbers first, but I think it's a good idea to gather all the variables and then gather the numbers. So, and Carolyn, after this, what do you think I'm going to do? Now that I gather all the variables, subtract 14 from both sides or add negative 14. Of course, when I do this now, what do I get here? How about Brianna? I can't hear, sorry? Negative 48 is correct. Okay, on the right side, you just have 8r. And of course, class, we're going to divide both sides by 8. And how many times does 8 go into negative 48? 6. Is it 6 or positive 6?
Negative 6.
I mean, negative 6 or positive? Negative 6 is correct. And so there's your answer. Any question?
Yeah.
Yes, sir.
I was just wondering.
Yeah.
If you had the original equation,
Mm-hmm.
we subtracted 2 from both sides first,
Let me see. Oh, yeah, you could have done that.
and then you divide the
Both sides by 4?
Yeah.
Yeah, that would have worked too. Very good. Very good. So Jason says, could we have gotten rid of this 2 by subtracting 2 from both sides? And since this whole thing is being multiplied by 4, and 4 goes into every term, right? You could do it that way, but this works too, okay? But that works because 4, if you divide both sides by 4, it goes into each other term. If it didn't, then you get some fraction, you see? So, because it's not going to always go in, right? So you don't want to avoid fraction as much as you can. All right, question?
If we cancel out the variables, we can simplify. Like,
If you cancel out the, what do you mean?
like, that 4r is negative 4r. If there's no variable.
Oh, okay, good question. Actually, just hold on to that thought. Let me go into the next equation because next question is going to address that. Okay, good. Hold on. All right, here's example 4. Go ahead and write this down. 3 times in parentheses x plus 2, close parentheses, minus x equals to 2 times parentheses x plus 1. Okay. As a matter of fact, I'm going to have you do this by yourself. Okay, so. Okay, everybody go ahead and try this example 4. Of course, you may ask your group. That's fine. Go ahead, I'll wait. Okay, who wants to tell me what to do next? I noticed some people are sort of discussing how to do the problem and so forth. How about, how about Lindsay? Tell me what to do next.
First, I distributed.
Good. You need to distribute that 3 and 2. Because right now, all the variables, the x's, are inside the parentheses, correct? So let's do that, and of course, when I do this, tell me what I write here, Eugene.
3x plus 6
Uh-huh.
minus x
Right?
equals 2x plus 2.
You got it. And I change it to addition. Is that okay? Yeah, I like addition. Because I don't want to make silly mistakes, right? Not forgetting negatives. Now, before I get going here, I should always simplify if I can. So who could tell me how I could simplify this here? How about, how about Bella? On the left side, I get?
3x plus negative x.
Right. Exactly. I get 2x plus 6 equals 2. 2x plus 2, right? Exactly right. Whoops. Oops. Okay. Now, Eunice, what should I do next? I have 2x plus 6 equals to 2x plus 2. Let's gather the variables together, right? How do I get rid of, so this time, you don't have to worry about which ones to get rid of because they're the same. 2x and 2x. So what do, Eunice? Subtract both sides by 2x, right? When I do, what do I get here? Paige, what do I end up getting?
Six.
6 equals to 2. I haven't got 6 equals to 2 at this point. Good. All right, Matthew, what do I do next? Why? That's exactly right. The answer is, if you get something like this, where 6 equals to 2, what does 6 equal to, Cos? 6 equals to 6. It doesn't equal to 2, does it? Right? Therefore, right, you get something that doesn't make any sense. 6 doesn't equal to 2. So that means, what this means is this equation, right? There is no solution is the answer. Which means there's no number you could plug in so that the left side would equal to the right side. So it is possible for equation to have no solution, okay? Many of you might have thought that, oh, right? Whenever we have an equation, isn't there always a solution? Not every equation. Okay? Some equations do not have any solution. For example, like this, right? You can see that no matter what you do, the left side will never equal to the right side. Yes, question?
Could you leave it as 2x plus 6 equals 2x plus 2?
Oh, you want to stop at this point right here? Why would you, then what? What are you going to write?
No solution.
Oh, because?
Because 2x plus 6 or plus 2 would have to equal the same thing.
Okay, sure. Okay. But isn't this a little bit more clear if once you do that, right? So I would like you to kind of actually go up to this point. Because yeah, some of you may see at this point, oh, 2x plus 6 will never equal to 2x plus 2. It doesn't make any sense, right? You're right, but then let's just take one more step. It's not that hard, right? Good. Yeah, question?
Could you put a line across?
Oh, good question. Do I need to put 6 not equal to 2 here? I guess you could do that, but we're solving an equation, and because we got 6 equals to 2, that's what shows us that this has no solution. So you can just leave it that way. That's fine. I know what you mean, because 6 doesn't equal to 2. Right? But if you write it that way, that's true, though. Right? So this is showing, oh, this is never true. So that shows you, that's the work that you're showing. Since 6 is not equal to 2, therefore, it has no solution. Does that make sense? And so, Samuel, have I answered your question? You were asked. Okay. Let's try next example now. Again, why don't you all try this one? Okay. 2 times in quantity of 3y plus 5, close parentheses, plus 9 equals to 6 times y plus 3, close parentheses, plus x. Okay. Go ahead. Everybody try. See what you get. I'll wait. Okay. And of course, again, you may talk to your members. Okay, that's fine. How about Matthew? What do you think we should do here? What's my next step? Yeah, I distribute because otherwise the terms with variables are inside the parentheses. So when I distribute, what do I get? Tell me what to write.
Get 6y plus 10 plus 9 equals 6y plus 18.
You got it. Now, of course, I distribute it this way. Then, of course, we should always... Mimi, what do I get when I simplify here?
6y plus 19 equals 6y plus 19.
You got it. That's sort of interesting,
I can
right? I get 6y plus 19 equals 6y plus 19, right? Huh. Anyway, let's move on. Let's just kind of keep on going, see what we could do here. Brandon, what do I do next? Let's gather the variables together. So,
Subtract 19.
oh, you want to subtract 19s? Can I subtract 6y first? Is that okay? Yeah, let's subtract 6y first, okay? Then, because that's what I did. I get 19 equals to 19. Isn't that right? Now, if you got rid of 19, then you get 6y equals 6y, right? So what does it mean? What does 19 equal to, by the way? 19. And if you got rid of 19, what does 6y equal to? 6y. So what does this mean?
identity.
What does it mean in terms of solution? In terms of solution. Spencer?
Y can be any number.
Y could be any numbers you want. So how are you going to write down your solution? Because, look, y could be 1, right? If y is 1, left side will go to the right side, right? Look at right up here. Hold on. You see, when you have 16, y equals 19, 6y equals 19, 6y equals 19, y could be 1, right? It'll be, y could be 1 million, right? Still, right? If y is 1 million, it'll be still, this is left side would always equal to the right side. Y could be negative 1 million, right? So it could be, so how would you write down your solution here? Aaron? Yeah, so you put a set notation, right? Real numbers. That's all. Because this is telling you that any numbers on a number line, right? Those are real numbers, isn't that right? Any numbers on the number line will work because left side would always be equal to the right side no matter what you do, right? Because you get this thing. Yeah, question?
Should y equal real numbers?
Oh, you could say that y goes to real numbers. That's fine too. But you could just, when we have x equals to 2 as a set notation, we just write 2 instead of set. Same idea here. Okay. Any other question? So the answer is real numbers. You could say all real numbers too if you like. It's up to you. I think it's the same. Any question? Are we good? So sometimes you could write all real numbers or real numbers. Okay, does that make sense? All right. By the way, there's a name for this equation that gives you all real numbers as your solution. Anybody know what this equation we had in the beginning? Because this came out to be this. The Auntie's equivalent, this sort of came out to be this, right? There's a name for this equation. Whenever the solution of an equation is all real numbers, anybody know what this equation is called? Yes? Correct. So sometimes they may ask you, what's the name of the equation then? It's called the identity equation. So write this down. An equation that is true for every value of the variable, which means the solution is all real number, right? Is called an identity. Yeah, which means it's the solution. The equation that is true for all real numbers. What does it mean? True for every value of the variable, which means it's all real numbers, right? So if the solution of an equation is all real numbers, that equation is called an identity equation. Does that make sense? You could kind of think of this as, look at, left side of this equation is identical to the right side. Isn't it? I don't know. Let's see that helps you. Yeah, question?
When we get our answer, do we have to write that it's
Good question. When they ask for a solution, what should we write? All real numbers with a brace, or should we write identity? When they're asking for a solution. All real numbers. This is your solution.
No.
Now, if they ask you, what kind of equation was that? Then you say, that's an identity equation. Does that make sense? So please be careful. On the test, if I ask for a solution, could you write down, the solution is identity equation? No, that doesn't make any sense. Right? We're looking for the solution. We're looking for the values of x that will make the left side equals to the right side. So if I ask for the solution, you need to write down what? All real numbers. Question? No, square up, down. Oh, okay.